I know. Maybe I should have like some recordings that I can just play. You know, like I press 1, and then I'll just have Schwarzenegger video clips in. Remember when I said when I killed you last? I lied. Yeah, actually, because if I can make a program that starts my video recording, then I'll just make a program that starts playing memes or something.
They can listen to what you say and then like what you say.
Oh no, not that advanced. Actually, yeah, I think maybe I will do that actually. I can have like hotkeys for certain memes or something like fail.
Or audios.
Audios, well the speakers don't work.
We can add sound effects to the class, I swear it would make the class so much more interesting.
Oh yeah, like when you get something wrong.
And the answer is
Yeah. So, you are wrong.
It'll get you more views.
Well, yeah. I'm doing okay. I have 160 subscribers.
How many views?
One per video.
It would be about an average of something like that, yeah. My biggest video has
6,000 something.
Yeah. I'm like, not bad. But it's not quite at the millions yet.
Yeah.
Once it's at the millions, I can start making money.
When did you start your channel?
4 years ago.
Is it 4 years ago? And it takes a while to build these things up now, you know.
4 years ago, and then like every year your class subscribes to it.
No, that's kind of more. I've been pushing the subscriptions more recently. In the beginning, I was like, whatever, but now I'm like, yeah, subscribers. Right. Do we have a homework to do, or did we do it in class for physics?
No.
We're in the middle of the lesson. That's right. That's right. Thank you. So we're on the.
But can you do one of the homework questions? I opened them, and then it wasn't really very pleasant.
Oh, from the states of Mar.
No.
But there were.
We started the idea.
Yeah, so I wasn't expecting you to do any questions in this because we're still in the middle of the lesson.
Okay.
But yes, we can have a look at them today in the class, anyways. Okay, so the last thing we did was the proof of the formula for the energy of an ideal gas. What was it? 2 over 3 or 3 over 2? 3 over 2 PV. Yeah, good. So we concluded that by increasing the pressure and the volume, you increase the energy stored in the gas. So in other words, energy is a product of pressure and volume. And what's interesting is that the 3 in the formula, in the 3 over 2, do you remember where that 3 came from?
From the soil. Group. Became a 3.
Tell me this, Faisal, is this true? Is this even true? Are you just playing with me? Yeah, where does the 3 come from in the formula?
Mu over
The volume.
No. Well, not really.
PV equals
You can be a bit more precise. No, hang on. Listen carefully to my question. There is a 3 in the formula.
The speed of the something because it's a 3D area.
That's it. Now we're pinning it down. The reason for the 3 in the formula is because it's 3 dimensions, which then makes you wonder if the ideal gas was in 2 dimensions, if we could have such a situation, then what do you think the formula might be?
2
over 2, so 1, so PV. And then you might get really crazy and say, well, what about if it was in 4 dimensions?
4 over 3.
4 over 2,
2
so 2 PV. So this leaves us with, although it's not part of the course, it's an interesting concept that the energy stored in the gas not only depends on the pressure and the volume, but it also depends on the number of dimensions the gas is occupying.
But in real life, isn't it always 3?
Yes, but in a more theoretical area of physics, you can consider situations when there's more than 3.
Like
4.
4?
Yeah.
What's the 4 then?
But you see, the thing is, we believe there's 3. We occupy 3 plus time. But there may be more that we just don't occupy.
Psychedelics and those kinds of things, and souls and...
well, not psychedelics themselves.
Then,
We just occupy tree.
yeah,
We
so
see tree, but that doesn't mean there's only tree. It just means we live in tree. Do you know what I mean?
yeah, but if we don't know of a fourth one, why are we calculating for it?
But there might be a fourth one.
Because we can't
And more.
get to it.
But
No, even on Mars, everywhere, it's always three.
Like the theory of multiverse.
that's it. And also the Large Hadron Collider,
What is this?
the huge particle accelerator at CERN.
Yes.
You know the large one. Is that it's
I think.
where's that? Geneva. Huge collider. It's massive. It's the biggest one in the world. It's like kilometers in size, and it takes particles and fires them at each other at huge speeds. One of the things they're trying to answer from these experiments is there more than 3 dimensions?
Oh.
If they hit them and one of them disappears, that means it's not.
Simple, but good enough for practice. More complicated than that, but essentially that's the idea.
Sean?
The Flash.
Yes, watch The Flash and the particle accelerator
The
explosion.
movie?
Yes,
Did you
no, the episodes.
Did you watch it?
Of course.
What?
Hello.
Good.
Yes.
Teacher.
Yes.
What is this?
Everybody knows it's a proven fact that if you stick yourself in a particle accelerator, you become a metahuman. It's basic physics 101.
Really?
What is this thing?
No.
Flash.
The Flash.
Superhero. Like,
Superhero.
Superman.
Yeah, so the movie.
No, there's no
Series.
The series?
Series.
The
The theory of
superhero
multiverse
theory?
and particle accelerator.
Come on now, deep down you're not surprised, are you?
I mean, like, you keep on complaining on how busy you are.
I need to do something in my free time. You know, I actually work when I'm watching stuff on TV. Anyways, before we start physics, since we're talking about the 3 dimensions, this might be interesting. There's a very good movie online called Flatland, and it's based off of a book from 1900s. And my physics teacher told me about this. It's a famous book, about 100 years old, and it's imagining a world where everybody lives in 2 dimensions. So everybody lives on a place called Flatland. And you have people which are triangles, people which are squares, people which are hexagons, or octagons, or whatever shape you have. Yeah. And the more sides you have, the more important you are. This is the idea. Now, you can imagine in Flatland, for example, if there's a wall here, then the people here outside, they can't see inside the wall. But you, not being in Flatland, you can see inside. So you can see where the others can't. Not only that, you can actually see everything at once, whereas the people in Flatland can't. And the example they have is, imagine you have a circle in Flatland, and you want to explain to the circle what is a sphere, you know, a ball. Will they understand what it is? No, because they've never seen 3 dimensions, they only see 2 dimensions. What would happen if the sphere tries to enter Flatland? What would the Flatland people see?
So,
They'd see a circle. So when the sphere touches it, they'll see a little circle. And then what happens when the sphere moves through Flatland? What happens? The circle will get bigger. So they do not see the sphere. What will they see? They will see a circle that expands and then contracts. So this sphere is in 3 dimensions. So now, imagine we are in 3 dimensions, but there is 4 dimensions. And the shape after the circle and the sphere tries to enter our space. What do you think we might see as it tries to enter? A sphere that expands and then contracts.
but that's saying that the sphere is a bigger sphere.
But are we saying the sphere here is a bigger circle?
But that's the thing, it won't be a sphere.
I know, it'll be something called like a hypersphere. Can we picture it? No, because we live in 3 dimensions. We cannot picture 4 dimensions. But if we try to picture it, the best we can do is imagine as it enters our space, we will see it as a sphere that expands and then contracts.
What about the 4D cinemas?
They're bullshit.
Yes, they are, thank
They
you.
just move the chairs
Yes,
and sprinkle water.
yes,
And
yeah,
have things to play with your legs.
that's all, that's all. So anyways, I thought it was an interesting movie, because then they have, in the movie they visit a place called Lineland. What do you imagine Lineland is?
One dimension.
One dimension. So in Lineland, it's funny because the only people in Lineland are a king, and then all the queens, for whatever reason. So in Lineland, they can only see what's in front and what's behind.
You can see one queen.
That's it. And can you swap places? No. So you're kind of stuck forever between whoever you were born between. No, that's it. Yeah. But imagine if you say here, oh, you tell the person, well, just go up. Well, they have no notion of up or down because they can only see left and right. So if you try to explain to them what's a circle, well, they can't. What happens when the circle enters? What would they see? A line, a dot, and the dot becomes a line, and then a dot again. Oh, I see, interesting. And then the last place they visit is Dockland. And what do you think Dockland is?
Okay.
No. Any ideas what Dockland is?
One king.
Empty
is like
place?
a dot.
Yeah, one person who is one dot.
That's it.
Yes.
Temporary.
And everything is that person.
Can
People paid
No.
to produce this
No.
movie.
Huh?
People paid to produce this movie. And people paid to watch it.
No, I watched that on YouTube. It is on YouTube, by the way.
How long?
It's a 90-minute movie.
It's a full movie.
It's a full movie.
Does it have a story?
Yes, it has a story.
Yeah, obviously they're going to different lands.
Anyways, I think it would be nice if you watch it. I just thought it was an interesting movie.
The homework.
No. Yeah, we can make it a homework then. Okay.
Jesus Christ.
Hang on, what are we at next now? Ah, yeah, this one here. Okay, so the next proof now. Okay, so imagine we have something like a liquid here. And you probably know this from basic physics, but what happens when something goes deeper and deeper into the liquid? What happens to the pressure? The pressure increases, and we would like a formula for this pressure. Yeah. Now, there's a couple of ways to do it. I think here I said to consider it as a sphere, but I think it might be easier to think of it as a cylinder or a disc. So imagine there's a disc here, and we'll call the disc, it has radius r, and it's a distance h under the water. So this will have a pressure from the water. But why does it have a pressure from the water? Well, it's like all the water that's above the disc is pushing down on it. So the pressure is the force over the area, but the force is the weight of the water. And what's the weight of the water? mg. And what's the area here for a circle? Pi r squared. Now, do we know the mass of the water? No. Or it doesn't have to be water, it could be any liquid. But we have the formula, density is mass over volume. So what is mass? Density by volume. So this is density by volume by g over pi r squared. Now, what is the volume? Volume is pi r squared h for a cylinder.
What?
The volume for a cylinder is pi r squared h. What cancels here? So you're left with this formula. Pressure is density times gravity times height. And what is missing from this formula? The radius.
You don't need the radius.
You don't need the radius. So in fact, This formula is the same even if you have no radius, even if it's just a point, or if it's a surface. The formula for the pressure only depends on what? The H underwater, the value of gravity, and the density of the liquid. If the liquid becomes more dense, then we have more pressure. Less dense, less pressure. And it's still true even if it's a gas. Doesn't have to be a liquid. It can be a gas.
So this is the formula for
Pressure at a depth of H.
But if you're underwater, you're not only experiencing pressure from above your head. Isn't that true?
Yeah, the pressure is all around you. So in this picture, I only consider it a disc. But it turns out the disc, it doesn't matter what the radius is, it's still the same pressure. So likewise, when I was going to do the sphere, it's more complicated, but you end up with the same result, that the radius wasn't important. So I just did the easier version of the proof and only considered a disc. But if you did redo this with the sphere and look at the pressure all around, so to speak, then you would end up with the same conclusion, but just a little bit longer to get there. Okay, the proof of this is not tested on the exam, but it's a very short proof anyways, and we'll look at some examples where you have to use this formula. Yeah?
So if a body is like moving underwater, the pressure would be acting more on it until the water is in the body, right?
Yeah.
Like, and when the water is in the body, then there's like
Now it's
minimum,
equalized then, yeah.
So how do submarine
They keep the submarine under a high air pressure atmosphere. So like the pressure will be more than 1 atmosphere, I'd imagine. But we haven't talked about that yet, we're about to. You writing this down?
And is it that we don't collapse because we have gas in our system?
You mean right now?
Yeah. Like
The pressure is not
Oh,
high.
because our bodies are used to the pressure of the atmosphere on us.
Yeah, but then like if we didn't have any air within our
If you suddenly didn't have any air, there'd be more concerns than the pressure on your body, you know.
Is the pressure around us enough for like collapse?
Are you collapsing right now from the pressure around you?
No, like if we didn't have air.
No. Even if you had no air in you and you were dead, your body would not collapse into a little
I read
ball.
about that.
Where did you read about that?
Like
On this
no, like I heard that
altitude, no.
I heard that like it's like the air in our lungs that keeps like it kind of equalizes with the pressure.
Sounds like you're reading fake science websites.
Yeah.
What website were you going to?
Fake science.
It was long.
Fakescience.com.
It was long ago.
Yeah.
Fully convinced by.
Yes, well, these fake science sites are convincing. Okay, we continue with this. So, we notice that when we climb a mountain, the pressure drops. And when we go underwater, the pressure increases, because we're changing the height. So, when we're actually on ground level, here's the Earth. Here you are. There is actually a pressure because it's like you're under air. Instead of being underwater, you're under air. So the pressure you feel is equal to the density of air, a big or a small number. Small. Do you remember what it is roughly? No, do you remember what it is roughly? It's about 1 kilogram per meter cubed. GH. Anyways, this pressure is on us all the time, but we don't feel it because we're used to it. And this pressure is called 1 atmosphere of pressure. And the definition of 1 atmosphere of pressure is 101.35 kilopascals, which actually is a lot. And it's amazing to think about how we don't notice this because we're used to it. Because from the moment we're born, this is the pressure that's around us all the time.
So if someone was born into the high pressure.
Dude, stop with these websites.
No, but seriously, like if someone was born with like 200 kilopascals.
If some alien, let's say a Superman-like alien, came from a planet that was 200 kilopascals, then they will feel less pressure here. It'll be the same effect as when you climb up a mountain, you feel less pressure. This isn't necessarily a good thing because less pressure means less air in your system. You know? And likewise, if the alien came from a planet that was 50 kilopascals pressure, when they came here, the pressure would feel twice as heavy, so twice as strong. So it's like for us, if we went underwater, we'd feel more pressure. Again, this also isn't a good thing. Yeah. But this is the pressure we are used to 24/7, 365 days of the year.
So if you take this number and divide it by 9.81, you get the height.
Essentially, yes. Yeah.
So
Which is that's a question later, so don't be surprised yet. Okay. Right. So can you make note of this? 1 atmosphere of pressure at sea level is the convention, is this much, and I think that's pretty big. 100,000 newtons per meter squared.
is that a real value?
No, I made it up. I got it from takescience.net. That's a real value.
So that's where the ozone layer is.
What is?
The height, like.
No. The height is just where the atmosphere, as we feel it, extends. But it's kind of complicated because the atmosphere extends much further out from the Earth, but it's kind of not really useful after a certain distance because you can't breathe it. So you have like atmosphere, but then you have things like stratosphere and different layers. The one we care about is the one we can breathe, which is the one nearest to the ground. The ozone would be pretty far out. Like I have a feeling that you probably have to go through several layers of non-breathable air before you get to the ozone. Yeah. Okay, did you write this down? Yep. Now, here's a simple question for you to do. What is the pressure on your body if you're swimming 5 meters below sea level? Try this, please, on your calculator using the formula I just gave you. Let's have a look. You have an answer? Omar, I forget, were you here on Friday or not?
Yes.
Were you?
Yeah, Friday, yes.
Yes, you asked him where he was, and he was like, I have an exam on Saturday.
Oh yeah, you did your exam on Friday.
No, this week.
This Saturday, nearly a week. Yeah, you ready for it? Yeah. Okay, what answer did you get here?
49,050.
49?
49,050.
I don't want to delete this, it's so beautiful. Maybe I can store it in answer. No, it's gone. Oh well. Right, the formula is rho G H. So 49 kilopascals.
That's not all of it, is it?
That's all of it.
You don't add atmospheric pressure?
I suppose you could. To be more precise then, I maybe should have said, what is the pressure from the water then? Yeah. Okay. Now, here's another one for you. So this now, Yusuf, this is what you were dying to do. Using the formula I just gave you, calculate how thick the Earth's atmosphere is. You'll have to think a little bit about this, although Yusuf already knows the answer.
do you really watch Flash?
I haven't watched it in a while. I watched the first like 2 or 3 seasons. What season number is it on now?
3.
Then I must have watched the first 2 then.
Yeah.
Is season 3 ongoing or finished now?
They still, I think, have 2, 3 episodes.
Okay, because I might binge watch it then when it's finished. Yeah. Yeah, I might do.
Do you watch Arrow?
And Supergirl.
Yeah. Legends of Tomorrow.
No, that's garbage.
Yeah, I know. I agree.
Good. We're on the same wavelength then. It's terrible because I was really excited about it because the trailer of it, the Legends series, I'm like, oh, this is going to be awesome, and then like, kind of lame.
They are basically taking the worst characters from each series and putting all of them in one.
I don't even find the story that interesting. Terrible. Arrow's okay. I like Arrow. I've never watched Gotham though. It doesn't. I don't know. I was talking to someone about it and I said, so is Batman in it? And they're like, no. I'm like,
he is in it, but like the
as a kid.
version of him.
Yeah. So like, who cares about that? Nobody cares about Batman as a kid.
The story was really
Is it?
Yeah.
Okay. Maybe I prejudged it too much then. All right. What answer did you get here, Yusuf, for the H?
10,331.
10 kilometers about. Very good. So the pressure here is 1 atmosphere, which we said, what is that? 101.35 kilo.
Yep.
Look, hey, yeah, I'm doing it. So the pressure is this, and that pressure is equal to density. What's the density of air? It's about 1. I know it's not exactly 1, but it's about 1. And the G
9.81.
and the H is H.
Yeah.
So if I just divide my atmospheric pressure by G, I have it then.
Grams per meter cube.
For what?
For the density of air.
No, kilograms per meter cube is what we use.
Oh.
Now, Yusuf, this is roughly the thickness of the atmosphere of Earth. It's about 10 kilometers. Now, really, this formula is an approximation because this formula assumes that the density is the same, whereas it's not. Up here, the density is more or less. What do you think from here?
Yeah.
Less. So actually, the formula is not quite accurate. Really, there maybe should be extra terms in the formula. So the atmosphere is a bit thicker than we think. So in real life, you could probably go to 13 kilometers and maybe still be able to breathe. But then after this, although there is an atmosphere, it's not a breathable atmosphere. It's not the atmosphere we're familiar with. It's a different type of atmosphere. So the atmosphere we care about, the one that we can breathe, we have it as about 10 kilometers. But in fact, it's a little bit more. But as you can imagine, when you get to 10 kilometers, then you're starting to push the limits of if you can breathe it.
Where did Felix go?
Huh?
The guy that jumped.
Oh yes, now he was much higher than 10 kilometers and he needed to take an oxygen tank, I believe, with him. Yeah. Because he was pushing past the limit here. Yeah. Okay. So what we'll do, there's a couple of questions here. They're all actually quite short to do. And I think we'll do them now actually because they all just require one of the 2 formulas. So we can do them pretty quick then. We'll see how we get on then. Do you want to take a picture on your phone? Because I'll stop the video then. Or you can open it on your phone, yeah. In fact, I've already done question 1. Show the unit of PV is joules. I did that in the class. So you're actually starting at question 2. Okay, can I stop the video now?